This video is about using the law of exponents to simplify an expression. So before we start that, we're going to complete this table using a calculator to help us look at what happens with some exponents. So in the first row, we're going to have 2 to the n power, and they already plugged in 2 to the third for us, which they got 8. The next one then is 2 squared. So on our calculator, we're going to hit 2 caret, which is under the clear sign, 2, which is equal to 4. 2 caret to the first, which is equal to 2. Then we're going to do 2 to the 0 power, 2 caret 0, and we get 1. Then we're going to do 2 to the negative first, so 2 power, make sure you're using the negative sign next to the decimal, negative 1. That gives us a decimal, so we're going to hit math, enter, enter, and that gives us a fraction of 1 over 2. 2 to the power of negative 2 also gives us a decimal, so we're going to hit math, enter, enter to get our fraction. So 2 to the negative 2 is 1/4. And we're going to do it one more time with 2 to the negative third. So 2 caret negative 3, math, enter, enter, and we get 1/8. Now let's do the same thing, but we're going to use 3 as our base this time. So first we have 3 cubed, so 3 caret 3 is 27. Then we have 3 squared, so 3 caret 2, which is 9. 3 to the first, which is 3. 3 to the 0, which is 1. 3 to the negative first, which gives us a decimal, so math, enter, enter. So that gives us 1/3. 3 to the negative 2, which gives us a decimal, math, enter, enter. And we get 1/9. And our last one, 3 to the negative third, 3 to the power of negative 3, math, enter, enter, 1 over 27. So when I look at these questions, the first one is what happens to a number with the exponent of 0? So looking at this column right here, notice that when we had an exponent of 0, we always get that to equal 1. So what happens when a number has an exponent of 0? It always equals 1. So anything to the 0 power is always 1. There are some special occasions we'll talk about in a second. What happens when a number has a negative exponent? So when it has a negative exponent, look at all these negative exponents, we were getting fractions. So what happens when a number has a fraction? Into a negative, it turns into a fraction. Because what's happening is the number's being squared or cubed just like before, but now with the negative, it's going to move down into the bottom of our fraction. So let's use these ideas to look at negative exponents and 0 exponents. So 0 exponents. The general rule is that x to the 0 power is equal to 1. But we got to be careful because the 0 exponent only goes to directly what's next to that exponent. So in this case, 2 to the 0, we already did that one earlier. 2 to the power of 0, we got was 1. The same thing happens with w to the 0. It's also 1. Now, when we have negative 2 to the 0 without the parentheses, this 0 exponent is only going to the 2. It's not taking care of the negative. So in our calculator, negative 2 to the power of 0 is negative 1, because it's really negative 1 times 1, which is negative 1. So negative w to the 0 then is also negative 1. Now, when we have parentheses, it's telling the calculator we want everything to the 0 power, including anything that's inside it, which in this case is also the negative. So when we have parenthesis -2 to the power of 0, this is equal to 1. Same thing happens with parentheses -w. This is also equal to 1. Negative parenthesis 2 to the power of 0, we only have the exponent again going to what's in parentheses. That negative sign is out front. So it's really -1 times 1, which is -1 as we see on the calculator. Same thing happens with the w. It only applies to the parentheses, so this is also equal to -1. Now, a couple of other special cases is that the 0 exponent can also go with variables. So here's some other special cases to consider. In the first one, we have 3x to the 0. The x is only getting the 0 exponent, so it's really 3 times 1, which is 3. Same thing happens with the -10. This is -10 times 1, which is -10. Now, the nice thing about the next one is everything is in parentheses, so to the 0 power is just equal to 1. Negative parenthesis 9y to the 0 power. This 0 exponent's only going to what's in parentheses, so we have that -1 times 1, which is -1. Sometimes we're also going to see enormous expressions like the one on the bottom. Don't get frustrated or confused by everything that's in the parentheses. Because because it has an exponent of 0, all of this is just equal to 1. In the second one, everything in parentheses becomes 1, but we also have this -10. So -10 times 1 is equal to -10. So basically, if there's a number out front, it's going to be equal to that times 1. The 0 only applies to whatever it's directly touching. Negative exponents. So negative exponents, remember that 2x and 2 to the negative x are reciprocals. So when a number has a negative exponent in the numerator, we are going to move it to the denominator. Vice versa, when a number has a negative exponent in the denominator, we're going to move it to the numerator. So basically, the negative exponents are going to flip what part of the fraction they're in. So in the first one, we have 2 to the -3. Remember, we can write that over 1. So this 2 to the -3 now has to move to the bottom of our fraction. So in this case, nothing's left on top, so we're going to put a 1, 2 to the 3rd. Now, 2 to the 3rd is a small enough number that when I do 2 to the 3rd, I get 8, so I can continue to simplify. Only simplify if when you do the exponent, you get a 4-digit number or less. The next one, 1 over 5 to the -4g. So here's my exponent that needs to move to the top of the fraction. So this becomes 5 to the 4g. If you want to put it over 1, you can, but you don't have to if you're moving to a numerator. The next one, -j in parentheses to the -6n. So again, we can put this over 1 because it was in a numerator, and this needs to move into the denominator. So this is equal to 1 over parentheses -j to the 6n. The -j does not change when you move it from one part of the fraction to the other. Only your exponent's changing. The next one, 5 to the -2nd needs to move to the top, my numerator, so it's now 5 squared. And we can evaluate 5 squared is 25. In the next one, 3 over 4p to the -9w. Just like the 0 exponents, the negative exponent's only directly influencing what it's directly touching. So 4 is not part of that exponent. So when I simplify this, 3 and 4 get to stay in place. The only thing that moves is what had the negative exponent, so now it's going to be p to the 9w in the numerator. In my last one, x to the 5th, y to the negative 4th, z to the 7th, we only need to move y to the negative 4th. That's the only one that's a negative exponent. So x to the 5th gets to stay in place, z to the 7th gets to stay in place, and we're going to move y to the 4th down. It does not matter your order down in the denominator or the numerator, depending on where you're moving things. Make sure that you're only moving the number or variable with the exponent. Do not move negative numbers. So let's try a couple more examples. So in the first one, we have 4k to the negative 8th. K is what has the negative exponent. 4 doesn't have a negative exponent. It gets to stay put. So we're going to keep 4 in the numerator and then move k to the 8th into the denominator. In the next one, we have 8m to the 9a over 3n to the negative 12b. The only thing that has a negative exponent is this n. So that's the only thing that should be moving. So we still keep 8m to the 9a and 3 in the same place. The only thing that's moving is n to the 12b. In the next one, we have negative 4 m to the negative 3rd, 10k to the negative 2z. So the only things that have negative exponents are m and k. While 4 is a negative number, it doesn't have a negative exponent, so it gets to stay in place. So this becomes negative 4 on top, 10, z gets to stay put, and then we're going to switch, so k is going to move to the numerator, and m is going to move to the denominator. Now, one thing is that we know these two numbers, negative 4 and 10, can be reduced because we can take a 2 out of each of them. So this reduces to negative 2k squared over 5z m cubed. In our last example, the only thing with a negative exponent is j to the negative 4th. Everything else gets to stay put. So negative 4ab to the 2w gets to stay put. J to the 4y is going to move to the denominator, and there's nothing left in the numerator, so we're going to place a 1 there. Two to the negative 3, k to the negative 10, 4 squared over 4 squared, m to the negative 12. So when I look at this, 2 has a negative exponent, k has a negative exponent, m has a negative exponent. So when I move everything and switch, m's going to move to the numerator, and in the denominator we now have 4 squared, 2 cubed, k to the 10th. Now, we can evaluate 4 squared, which is 16, and 2 to the 3rd, which is 8. These are really being multiplied. So it's m to the 12th over 16 times 8, k to the 10th. So we can multiply 16 times 8 to further simplify. So we have m to the 12th over 128, k to the 10th. Our next problem, we have 9 to the negative 2, a to the 4th, c to the negative 100th, over, parentheses, negative 3 to the negative 4th, and b to the negative 8th. So we're going to move everything that has a negative exponent, 9, c, negative 3 in parentheses, and b to the negative 8th. So a gets to stay put as a to the 4th, and then we're going to have negative 3 to the 4th and b to the 8th join the numerator. And the denominator, we're going to have 9 squared and c to the 100th. Now, we can evaluate negative 3 in parentheses to the 4th. It's important to use your parentheses if they're there. So this gets us 81, a to the 4th, b to the 8th, over 9 squared, which is also 81, c to the 100th. Now, both of these are 81, so they reduce to 1, so we're left with a to the 4th, b to the 8th, over c to the 100th. Next example, we have 8a over negative 2 in the parentheses to the negative fourth. So this needs to move to our numerator. So we now have 8a times negative 2 to the fourth. So parentheses negative 2 to the fourth is 16. So we have 8a times 16. Well, 8 and 16 are both numbers, so they can multiply together. 8 times 16, which is 128a. In the next example, we have a to the negative 2, b to the negative fifth. Those have negative exponents. Negative 3 does not, so it gets to stay in the numerator, and we're just going to switch b into the fifth to the numerator and a to the second to the denominator. Now let's try some problems where we're going to put it together. So what you want to do first when we're putting it together is you want to look for any problem that has a 0 exponent so that we can cancel that part out of our equation. So in the first one, we already have a d to the 0, which we know is 1. So this leaves us with a to the negative 12th, b to the 15th, over c to the 15th. The next thing I want to look for is, do I have any negative exponents? So I have a to the negative 12th, which needs to move into the denominator. So I'm left with b to the 15th over a to the 12th, c to the 15th. Number 2, I need to look and see, do I have any 0 exponents? I have negative 4 in parentheses to the 0. So because everything's in parentheses, that's just equal to 1, and that leaves me negative 5 times x to the negative fifth. X to the negative fifth has a negative exponent, so we're going to move it into our denominator. So we're left with negative 5 over x to the fifth. Number 3, there are no 0 exponents, but we have a negative exponent of v to the negative 12th. Now, negative 3 is not connected to that, so negative 3 gets to stay in the numerator, and we're going to move v to the 12th into the denominator. Number 4, I have a 0 exponent with this whole parenthesis. So the parenthesis becomes 1, and I'm left with 2 times h to the negative 12th. H to the negative 12th is a negative exponent, so 2 stays in the numerator, and h to the 12th moves to the denominator. Number 5, first thing I want to do is I want to look for any 0 exponent. So I have x to the 0, which means that becomes 1, and I am left with negative 8 times y to the negative 1, m to the negative 20th. We're looking for negative exponents. So y to the negative 1 and m to the negative 20th are going to move into the denominator. Negative 8 doesn't have a negative exponent, so it gets to stay in the numerator. So I have negative 8 over y, m to the 20th. You can put the 1 exponent by the y if you want to, but you don't have to. Number 6, we have 11d to the 0 in parentheses, so that becomes 1. We're left with 1 over j to the negative 8th, m to the negative 15th. So I have 2 negative exponents again, which need to move. So because they're in the denominator, they now move to the numerator, j to the 8th, m to the 15th. If you want to put them over 1, you can, but you don't have to put the over 1. Number 7. Looking at number 7, I find that this parenthesis has a 0 exponent, and this y has a 0 exponent. So those become 1, and I'm left with 3 times 5 to the negative 5th over negative 4m to the negative 7th. So I need to move my negative exponents of 2 to the 5th and m to the negative 7th. That gets me 3m to the 7th over negative 4 times 2 to the 5th. So I can simplify this bottom. I can just put it all into the calculator, negative 4 times 2 to the power of 5, which gets us negative 128. 3m to the 7th over negative 128. We can just take the negative sign and move it out front. I want to double check, does negative 3 divided by 128 reduce? So I'm going to put that fraction into my calculator, math, enter, enter, and in this case I get the same fraction back, so I can't reduce that at all. Let's look at 2 more problems. So explain the error in complete sentences and then simplify correctly. So in number 8, what's the error? The error is that the negative exponent only applies to the m. So this should have been the only thing that moved. So 2 should have stayed in the numerator, and then m squared moved to the bottom. In number 9, what's wrong with this is that our 0 exponent should only apply to the parentheses. It doesn't apply to the 4. So the 0 exponent doesn't apply to the 4. So it only applies to what's in parentheses, which makes that 1. So 4 times 1. So our correct answer should have been 4.